Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are in the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome to the program. I hope that you're doing well and you are ready for today's show. Because today on the show, you may have guessed, Ralph Bond. He joins us every single Friday to talk about science and technology trends. And ladies and gentlemen, he has a number of fun stories really lined up for us. They're going to be very interesting about how the brain works, how it makes decisions. It's going to be about solar cells, green technology. It's really going to run a nice broad range to really highlight that science and technology, regardless of what happens in the world, there will be that undercurrent of people doing interesting, cool, productive, good research. And, hey, good things are going to come from technology. So that's definitely what we like to highlight in our segments. And Ralph does an amazing job of that. Before we get started, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, articles, everything that you need to know about Computer America, you can find right there, including links to all social media if you'd like to give us a follow there. And on top of that, you can find the past shows. We even have an entire section dedicated at the top to Ralph Bond, where you can find just his stuff, past shows. And don't worry if, it's like, man, I haven't seen Ralph in months. Hey, go back and check out his past shows because they are definitely, not as time sensitive as, the latest iPhone release that happened earlier this week, for instance. No, these are a little bit more, future looking, and it's always a lot of fun. So without any further preamble, let's go ahead and bring Ralph on and just have fun with it. So once again, he is our science and tech trends correspondent, and you'll find out what that means in just a moment. But welcome back onto the program, Ralph. Ralph, how you been?
And friends, if you're brand new to the show, whether you're listening to us as a podcast or watching us on YouTube, let me explain what we do. Ben and I, each Friday, what we do is we highlight 4 recent articles that show us, and here's the important part, key trends and developments in a host of things: artificial intelligence, of course, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, construction technology, space research, physics. Wow, you name it, all across the board. But here's the key, most important of all, especially given the news week we've had this week, tragedy and horrible things going on. The most important thing we're going to do is going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And before we get into that in particular, though, I just want to say that this week's news cycle was very crazy. Started out on a high note, seeing what Apple's, kind of doing. But then, there was the obvious event that happened this week that, we're really not going to talk too much here on the show. But, violence is awful. I don't think that really needs to be said, but here we are. And then this week was always going to be an emotional week because obviously, we are here on September 12th, September 11th, of course, just happening. And, that's always going to make for a heavy week. So, yeah, just wanted to give a quick little nod to the fact that September, 11th just happened, and that, even after all these years, it's still so, I guess, kind of encouraging because I think everyone knew it's almost like a defining point for a lot of people that lived through it, where it's like you knew where you were, you knew what you were doing, and it was a time when everyone really stopped and took notice of a singular thing, and that really brought, I think, a lot of people together. So, it still does that 24 years later. And remember those who, of course, suffered, who continue to suffer, and the families of those who were affected. But yeah, I think everyone really was. And Ralph, I saw, just on our personal Facebooks, you posted some pictures and some heartwarming words. It was, I think more of that this week was, good to see.
Yeah, absolutely. And very quickly, I'll never, ever forget, a few weeks after 9/11 happened, Microsoft had a huge launch of their latest version of their operating system. And Intel, of course, I was with Intel Corporation at the time, and we were involved with the launch and so forth. And our manager said, folks, you don't have to go if you're afraid to go. And my daughter at night at dinner said, nope, Dad, you need to go. You need to show support for the people of New York. And so I went. I'm glad I did. And I'll never forget taking the Fulton subway station. I believe that's the correct station. I went up and I saw the massive pile of rubble. For example, you may remember the scene where President Bush got up there with the megaphone and so forth on the pile of rubble. Well, I saw, not him, but I saw the pile of rubble still smoking. Very weird smell to the whole area, and it's just burned into my memory for life. But that's sad, tragic stuff.
Yeah.
We're going to lift you up now, starting with story number 1.
Absolutely. Yeah, no, just want to give a quick nod to it. But yeah, that is not the point of our show. There are plenty of other places to find stories such as that. But today's show, like we said at the beginning, is focused on science and technology. And Ralph's right. 4 different stories, starting with story number 1. And yeah, we get to find out how the brain works, because I've been trying to figure mine out for many years, and it does not work in all regards. So, Ralph, story number 1.
So true. This first one comes from livescience.com. The headline is Map of 600,000 brain cells rewrites the textbook on how the brain makes decisions. And this is just such an interesting example of research. I just couldn't resist it. Here we go. A massive neuroscience collaboration from an outfit called the International Brain Laboratory. And by the way, that's a global neuroscience collaboration. And their website says experimental and theoretical neuroscientists collaborating to understand brain-wide circuits for complex behavior. Wow. Well, this team of international researchers and scientists, they've created the first comprehensive activity map of a mammalian brain during decision making using data from over 600,000 neurons tested across 139 mice. Once again, we've talked about this before. I think we need a national monument in honor of rats and mice and pigs to thank them for their contribution to science.
Yeah, the image up on the screen, is kind of the blown out view of the rat brain that the kind of is.
Right.
And I saw just faintly, you can see the outline of the rat in the background, and like it didn't really catch on until I was like, oh wait, okay, rat brain. So but yeah, it's always fun to me, Ralph, that it's like, the most cutting edge research, like when you look at it from a layman's point of view, kind of zoomed out, you're like, looks like a 2-year-old drew, scribbled on a paper. But no, this is very precise mapping, and it's the precision is insane.
Oh, it is. It's remarkable. And going on with the story, this effort spanned 12 labs across the globe and covered more than 95% of the mouse brain, in this case, mice, not rats, challenging long-held assumptions about how decisions are processed. So let's get into this long-held assumptions, which the article does a good job doing. So contrary to textbook models, decision-making is not localized in the brain to a specific area. This was the prevailing belief. The research revealed that decision-related signals were found across nearly all brain regions, not just the visual or prefrontal, if I could say it on Friday, prefrontal cortex. And in the show notes, I have a little section here, and this is what I do with the show notes. And by the way, we should stress this, come out to computeramerica.com. For each of these shows, we have what we call the show notes. These are a copy of my notes that I'm reading from right now, and it gives you links, additional information, and I insert little tutorials when I don't understand something or when I think it would be helpful for our listeners and viewers to see. So in this, I have a little side note that explains the whole bit about prefrontal cortex and decision center and what the prevailing belief was. Historically, that was seen as the brain's executive hub responsible for rational thought, planning, and impulse control. But this research says, wait a minute, no, there's a wider range of brain activity or brain contribution to decision making than just that. So you can go in and look at that little aside that's inserted. And then let's talk about how the research was conducted. Using a standardized experimental process, the International Brain Laboratory team trained mice to respond to visual cues by turning a wheel, allowing researchers to track brain activity in a consistent, reproducible way, I should say.
Mm-hmm.
And when visual cues were faint, mice relied on memory of previous trials, revealing that expectation-based decision signals were also widely distributed in the brain instead of being just concentrated in one part of the brain, as we said before. And you might ask yourself, okay, that's interesting, but why is this significant? Well, this work redefines how scientists understand the brain's decision-making architecture. It sets the stage for future research into the relationship between a cause and effect, not just correlation in brain activity and behavior. And Ben, we also always stress what we do with these little highlights for each of the 4 articles today is just give you the essential nuggets. If you want to dive deeper, the show notes have the links, research paper links, all kinds of good stuff. Please come out and check that out.
Yeah, and I find myself even just referencing your side note that you had put in there, where I think traditionally you have the decision making part of your brain, the frontal cortex does this, and the side does this, and that does that. Trust me, don't listen to Ben on brains. But anyways, according to your notes, and it's it turns out that apparently it's kind of trailing all throughout the brain. It's all interconnected. There's no one singular part of the brain that does one singular thing.
Right.
Yeah, it's very, very interesting. And I could see how in the course of drugs and surgery and medicine, that could be very helpful to know how it works. So.
Yes.
Very, very cool. And again, thank you to the mice who lent their brains for this study. And honestly, 600,000 different brain cells. That's really amazing that they're able to get that kind of fidelity. So amazing research. So love story number 1. Ralph, story number 2, and this is the one about green energy. Solar cells, if there's one thing I think, ladies and gentlemen, know about solar cells is that, right now, the main place you see them is on top of roofs, on buildings, on whatever, very inflexible, rigid panels that never move. They of course have motors that kind of flip the boards themselves, but, the flat surfaces, but they don't themselves bend. They don't curve. They aren't wrapped around a pole or something like that, Ralph. Maybe some actuation, maybe some movement, and, being able to put it on surfaces that are not just rigid, flat surfaces might be a solution to getting more solar panels out in the wild. And I think that's where we end up with story number 2.
Yeah, story number 2 is great. It's from interestingengineering.com. And the headline, which I'll say a comment about in just a moment, the headline is Super Solar Cells Withstand 10,000 bends or flexing, retaining over 85% of output after 2,800 hours. But what the headline doesn't tell you about, which is really, frankly, the most significant part of this research that we're going to talk about, is solving a problem that heretofore has made making solar panels or solar cells out of perovskite, and we're going to talk about that in a moment. That was not a very practical thing to do because it costs so much to produce perovskite solar cells. This research really addresses a key barrier in that, opening the door for commercial production. So that's interesting to me that the headline talked about the bending and the flexibility, because we've seen other flexible, bendable solar cells in previous shows and previous research. So let's get into this, though. It is a really great story. So researchers at the Korea Institute of Materials Science have developed a new material and fabrication process, ding, 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 that's important, for flexible perovskite solar cells, enabling their production in ambient air conditions. This is the key. We'll explain that. Now, in the show notes, once again, I've inserted, Ben and I are familiar with perovskite, and we're familiar with why it's so attractive to the solar panel industry. But if you're not, in the show notes, I've got a little section here. What is perovskite and why is it important and where it matters and all that good stuff. But I will say, I will read the part about why it's important for the solar energy technology community. Well, perovskite has been a material of intense interest for replacing conventional silicon in solar cells due to perovskite's excellent light absorption properties and potential for low-cost production as thin, flexible films. So there's the setup here, and please come out to the show notes and get more information if you're not familiar with perovskite.
Yeah, it's really amazing stuff that we're, so many times before we've been hoping revolutionizes the solar panel industry, and it's, it is making its way out there, but it's not quite there where it's in every single, solar panel being made out there.
Right.
But it's nice to see that it's not just more efficient than old solar panels. It's not just, cheaper than old solar panels, but hey, it's going to lend some of its other unique properties to it as well. And, like you said, through different manufacturing processes. So
absolutely. So picking up again on the story here, it says, in addition to creating a flexible perovskite solar cell, which is great. I mean, that's a good thing. The Korea Institute of Material Science Research also directly addresses perovskite's significant vulnerability to moisture, a long-standing barrier to its widespread commercial use. So there's the vulnerability to moisture and manufacturing challenges for perovskite that to date have made it not that attractive. I mean, attractive technically, but in terms of reality implementation, big barriers. And this research from South Korea really addresses some very important heretofore barriers going on. Perovskite's chemical instability in the presence of moisture has historically necessitated manufacturing in controlled, low humidity environments or inert gas atmospheres, which requires expensive, specialized equipment. So perovskite itself has great light absorbing capabilities that outperform current solar panel technology. All that's great, but to make the stuff, to make panels and to make flexible sheets of solar capturing energy was too prohibitive in terms of the need for specialized equipment. See the picture here on this? Pretty interesting. So to solve this problem, the Korea Institute of Material Science team implemented what they call defect passivation strategy, okay, which involves sandwiching the primary light-absorbing perovskite layer between two protective layers of a two-dimensional perovskite material. And if you're going, I'm with you there. You need to read the research paper if you're a geek to really fully understand what they're doing.
Ralph, it's right there. They made a solar. They made a solar. They made a solar panel sandwich. It's super simple. It's just a sandwich. Bread, stuffed bread. I mean, yeah.
Yeah, it's a perovskite club sandwich.
Exactly.
And then the resulting solar cells that they created that are flexible, as you see in the picture in the show notes and so forth, have great durability. In longevity tests under operational conditions, the cells successfully retained 85% of their initial efficiency after 2,800 hours. And they also, in terms of flexibility, proved their mechanical resilience, maintaining 96% of their initial efficiency after undergoing 10,000 bending cycles. Okay. And then to wrap it up here, as we were alluding to earlier, the key significant benefit of this research from South Korea, salute to South Korea, has to do with overcoming the chemical instability of perovskite in the presence of moisture, as we mentioned before. The ability to manufacture in, here's the key, open air conditions without extensive environmental controls presents a direct path toward reducing production costs of perovskite solar cells. This is a very important, significant milestone in research in the world of solar panels and making perovskite a viable contender.
Yeah, as soon as it's certainly able to do something like that, and I apologize for the barking dog, but perfect timing. But as soon as it's able to make its way out of the lab and into people's homes, and it's cheaper, more efficient. Ralph, like at some point, you're going to hit that tipping point of economics where it's just, hey, what's the cheapest way to get electricity? And maybe an array of solar panels won't just be like a luxury, nice if you can, pay itself off in 10 years kind of thing. But it's like, hey, after 1 year, it starts paying for itself. And at that point, you're going to see solar panels everywhere. And you just need to be able to make them. And this solves the being able to make them part. So perfect.
Yes. Very exciting.
Perfect. Yep. Perfect. Story number 2. Story number 3. Let's go ahead and bark our way over to story number 3, where we have a robotic touch. And, this is, this is something that I think robots, and even though Elon Musk said that 6 months ago, we're going to have robotic, humanoids everywhere. The idea of having robots in our everyday lives is still kind of hampered by the fact that robots don't really sense, see, and interact in the world the way that we do, and that makes them very dangerous. You don't want a robot arm, punching through you as they try to open the door, something like that.
Yes.
Very, very, robots have to be careful, and teaching them to see and sense and touch things is, not really a strong suit, but we're working on it. And story number 3 seems to be research aimed at, well, how do we make robots safer?
Yes. All excellent points and a great way to set up this story. This comes from techexplorer.com. The headline is Soft Skin, Sharp Senses. And the subhead, New Robotic Touch sees danger before it hits. And the word sees and touch in the same sentence might be in what? Wait a minute. You'll understand as we get into this. Is very interesting. And Ben, you and I have covered so many stories about artificial skin for robots and this and that and such and so. This takes it to a whole new level, which I just think is absolutely fascinating. And we've got some great illustrations from the research paper in the show notes, so check it out. But here we go. Robots are becoming increasingly integrated into everyday environments, from homes and hospitals to factories and farms. That's a little bit of an overstatement, but that's okay. However, as you pointed out, Ben, safely operating around humans requires more than just strength or speed, needless to say. Here's the key to this research. Robots must also sense their surroundings, detect physical contact, and respond quickly. Conventional sensors for robots so far, especially those embedded in soft materials, often fall short when it comes to real-time, large aerial, tactile, and proximity sensing. And proximity sensing. Let that sink in.
Yeah. I think a really cool example of this, while it's not exactly a robot, some of the safety features that come with, and I'm not good with power tools, but I think it's just like a bench saw, the one that has kind of the saw blade embedded in the workbench, Ralph. Back in the day, hey, anyone who used them, they were missing a few digits, at least the tips of their fingers. They were missing a couple. Nowadays, you get the newer ones that actually can touch, you can, I guess if you had a hot dog, you could touch a hot dog to it. But, people still, you touch it with your finger, the blade drops down, saves your finger from being cut. That kind of immediate sensing of skin in human contact and being able to respond is a good example of like what they want to do with all robotics. They want to make sure that, hey, if something goes wrong, if a human is in the way, touches or moves, that, it doesn't just cut the human in half. They want it to stop. So.
Yeah. And I'll give you a little preview of what we're going to talk about here just in a second. Imagine a robot with skin that can not only sense when it's been touched, but sense when something's coming toward it to touch it. That's the proximity thing I just mentioned in the previous
That'd be
comment.
amazing.
This is really something. So here's where we're going with this. So to address this challenge, a research team from the Japan Advanced Institute of Science and Technology developed something they call PROTAC, PROTAC, a novel, get this, vision-based soft sensing skin for robots. I'm going to say that again. A novel vision-based soft sensing skin for robots. Wow. At the core of ProTac is a polymer dispersed liquid crystal layer that can switch between transparent and opaque states when voltage is applied. This is so weird. The ProTac solution uses transparent, embedded cameras that can see through the skin to detect nearby objects. That's the issue of proximity. When opaque, these same cameras track how the skin deforms, allowing the robot to sense touch, pressure, and location of contact. That's so important, location of contact. This dual mode sensing enables real-time environmental perception using a single soft layer, eliminating the need for complex embedded electronics. Wow.
Yeah, and yeah, like you just said, they're eliminating the need for complex embedded electronics. It sounds like they eliminated the need for complex embedded electronics by embedding complex electronics, because that does not sound simple. That sounds very complex.
Well, it's a single layer, and it's
True.
got these sensors that can, whether it's opaque or transparent, determines whether these camera sensors can do their job or not. So it is compared to previous technologies that try to do this, it is less complex. So let's get a quote from a lead researcher on this project. Quote, "This innovation with sensor design simplicity allows robots to perceive both contact and nearby obstacles across a large area skin in real time, which is difficult to achieve with conventional electronic skins." So it's simpler and lower parts, if you will, which is kind of interesting. And to validate their design, the team developed a prototype, again, they called the ProTac Link, a cylindrical robot arm segment wrapped in a soft sensing skin and equipped with stereo cameras at both ends. So that's what's shown in the illustration from the research paper that Ben is showing on the screen right now. And to wrap things up, this prototype can detect approaching objects. Wow, can detect approaching objects, not things that have touched you yet, approaching objects from multiple angles, can estimate distance and recognize multiple touch points with high accuracy. It also supports adaptive behaviors such as proximity-based speed adjustment and reflexive contact avoidance. Wow.
And looking at the images, you can tell that this thing is, still pretty. I mean, obviously, all of this is research, but it's still pretty large. But to be able to do something like that, and like you said, to see things incoming before it even touches and doesn't even have to respond, wait for a touch to respond. I could see this in so many situations, and not least of which is just these robot dogs that we see running around, or we see these robots. Ralph, I'm thinking like those automatic floor cleaners that you're seeing in more and more stores and shops. Being able to see your environment is crucial to getting robots into our lives, and this seems like a very promising lead. Yep. Very, very cool. And again, if you want to see pictures and you want to see the research, come out to Computer America, get the show notes, and you can see all of it right there in the show notes. Very cool images. I hope to see more of that one. That seems like a great way to introduce robots into more places. So story number 3, ladies and gentlemen, if you're following along, our last story for the day will be story number 4. There's more, but we'll get to that after the story. And let's talk a little bit about, a couple of months ago, or even like 2 years ago now, I think, we did a story about pants that you can wear while hiking, and they can help you hike longer and further, and kind of help you on your hike if you feel like you need a little bit of robot boost. Well, story number 4 might be the thing you need to complete your ensemble, because this is going to be for the upper part. Ralph.
Yes, yes. And what we do with Story 4 is usually look at things that are either in the medical science technology field or in the area of helping people with impairments, technology to help people that need an extra help for walking or moving and so forth and so on. And this fits that story. This is another story from interestingengineering.com, one of my favorite outlets. Headline: Soft Wearable Robot Jacket Responds to Movements, Supports upper limb impairments. So it's aimed at helping people who have upper body, arm, hand impairments regain movement. And that's the purpose. We've got the research paper link in here, all kinds of good stuff. Video as well, as Ben is showing pictures and videos. And let's get into this. Engineers at Harvard have developed a soft, wearable, robotic jacket designed to assist individuals with upper limb impairments, such as those caused by stroke or ALS, amyotrophic lateral sclerosis. Okay, so that's the target audience for this robot jacket. The robot uses a combination of machine learning, there's your artificial intelligence, of course, and a physics-based hysteresis model to learn and respond to each user's unique movements. And if the word hysteresis made you go, what? Like it did for me at first, I've heard of it, but I needed a refresh on what that is. By the way, that refers to a system's tendency to lag behind changes in the forces or inputs acting on it. In other words, the output doesn't just depend on the current input, it also depends on the system's history. So a history of experience that the system learns. And I've got more inserts here if you want to check out more about hysteresis. You can do that as well. But going back to the story, the Harvard wearable robot jacket decodes motion intention. There's a key: motion intention, using sensors, and adjusts support dynamically based on the user's kinematic state. All right, so in specific, the sensors employed are called inertial, am I saying that right? Inertial? Yeah. Measurement units, or IMUs, inertial measurement units, which is a sensor that tracks body motion and orientation and compression. And I've got another side note about kinematic state if you want to learn more about that.
Yeah, it seems like, I guess people would be used to accelerometer, but I don't think accelerometer measures pressure and compression. So I guess that's the main difference between accelerometer and that one.
Yeah, it's pretty interesting stuff here. And the new Harvard device helps disabled users perform everyday tasks like eating and drinking, offering both assistive and rehabilitative benefits as well. So that's cool. And to wrap it up, the project involved physician scientists from the Massachusetts General Hospital and Harvard Medical School working as a team, ensuring medical relevance and testing with actual patients. So another wonderful breakthrough to help our folks that have physical disabilities, whether it's the lower part of the body, upper part of the body, whatever the case may be. How wonderful. A great way to end on a upbeat note.
Absolutely. Yeah. The video that we showed that you can, see in the video portion after this, if you're just listening to us, but the video that we showed, they, it doesn't take all of the physical, kind of movement away from the person. It's not like, okay, suit off and, it's, kind of slow, jittery, shaky, halting. And then, machine on, and it's just like robotic, it's not like that, but you can definitely see a very clear difference between the befores and the afters in so many different patients. And Ralph, I mean, as for non-intrusive, I can't think of a medical device, and I know that we're talking about Harvard here, but I can't really think of a medical device, even at the research stage, that seemed to be this unobtrusive, because it's very form-fitting. It's not like a big bulky thing that you slip into. It's very it's very unobtrusive.
Right. Ben, to your point, it's not an exoskeleton, which we've seen a lot of those where you just climb into a thing and it helps you move around. This is something you just literally put on a jacket.
Yeah. Very, very sleek. And I could definitely see that, this research going even further and helping people, fully rehabilitate or just assist in everyday life. It's very, very cool. So, ladies and gentlemen, there you go. Thank you for following along with that. And if you've been watching and following along in the show notes, because by the time that you hear this, the show notes will be available for you to check out. You may notice that, hey, that little bar off to the right on your screen is only like halfway down. Well, there's a reason for that. Below story number 4, you will find honorable mentions. And these are stories that are just as cool, just as great. If you're a researcher and you're listening to this and you're like, aw, only honorable mentions, I got to spend the next 6 years trying to get into the top 4. No, it's not a top 4. It is just it's just a list. And Ralph puts honorable mentions to highlight that there is more amazing stuff going on out there. And, you should know about it. So we don't have time on the show. We try to condense the show a little bit. But Ralph, we can at least give the nice folks the headlines. They can come out to Computer America. They can find the links and they can learn more about these themselves. But yeah, let's at least tantalize the stories.
Absolutely. This first one will have 4 honorable mentions. First one from ZME Science. Headline: Some people are immune to all viruses. When I saw that headline, I went, what? I had no idea. Scientists now want to replicate this ability for a universal antiviral. Can you imagine? Wow. I mean, the implications of this are so profound. Please check this out, folks. It's fascinating if you're interested in medical technology.
Yeah, it definitely seems like the opening to some kind of sci-fi horror movie. It's like, we thought we were eliminating viruses and then we became the virus, something like that. But no, it's good.
Yeah,
it's good.
Yeah. And the next one, in the story 2 in the honorable mentions, from phys.org, short for physics.org. Headline: Generative AI designs compounds that can kill drug-resistant bacteria. And just a couple of notes from this. This is from MIT. The MIT researchers used generative AI to create novel antibiotics targeting 2 dangerous pathogens, and over 36 million compounds were designed and screened computationally through the AI. Wow, great story. Dig into that, folks. It is amazing. The next one also comes from ZME Science, a wonderful outlet, by the way. And it says, this new indoor solar cell could power the entire Internet of Things, small devices, using only the light from your ceiling. Wow. I mean, this is really intriguing stuff. Check it out. I love that story. And our last honorable mention comes from the Pacific Northwest National Laboratory in the state of Washington. As you know, Ben, I nicknamed these guys the MIT of the West Coast. These men and women are absolutely amazing. Headline here: researchers explore biomining seaweed for critical minerals. So what they're doing is they're exploring seaweed as a sustainable source of rare earth elements and other critical minerals like nickel and cobalt and more. What?
Because
from seaweed?
We had heard in previous stories that Ralph had brought us, and the music in the background means that we're going to kind of wrap it up here. But I remember from previous research, Ralph, that that you had brought to our attention that those rare earth metals that we keep talking about, they are all in the water, in the ocean. They're just diluted and floating around in little particles all throughout the ocean. We've seen desalination plants try to get access to them and kind of harvest them that way. And hey, Pacific Northwest National Laboratory seems like they're going to go after the seaweed, which, let's all face it, we all agree it's gross. So it's good to find a use for it. Very, very cool. So there you go. Ralph, I want to thank you so much for coming on the program, talking with us and outlining all of this. It's been amazing. And ladies and gentlemen, if you want to learn more about the first 4 stories or even the next 4 stories, computeramerica.com, Ralph Bond segment, first one right there. And until next time, I want to thank you so much. Thank you, Ralph. And everyone, have a good weekend. It's going to be okay, everyone. And yeah, we'll catch you here every single Friday with Ralph Bond. Until then, have a great day. Thank you so much. Bye, everyone.